Okay, students, you are taking notes today on circuits. This is your last part for your test on Friday. Normally I would have a really awesome demo with an Easter chick, but I won't be able to show that to you yet. I'm hoping to put that video up tomorrow and talk the sub into how to do it with the ones at school. It's really neat to understand circuits. But as you can see from on screen, a circuit is just a complete closed path that electricity flows, or your current. Remember, your current is your moving electrons going from one end to another. As you can see here, this is a complete circuit, a complete path. It goes from one end of the battery into a light bulb all the way to the other end. If there are any holes or gaps in the circuit, the current will not flow. Think of this as a road. If you're traveling on a road and you have to go through over a lake or a bridge, if there's no bridge there, you can't pass it. Same thing with electrons. If there's a hole in the road, a hole in the circuit, electrons cannot jump that gap and the electricity won't flow. In other words, your light bulb will not turn on. With any circuit, you have three major parts. Your three major parts that every single circuit has to have. You have to have, obviously, wires, an energy source or your voltage source, and what's called a load or resistor. Now remember from your notes from last week, voltage is your energy source, it's your power. In our case, our voltage source is going to be a battery, but again, voltage could be anything. It could be a battery, a thermocoupler, an electric generator, or a power plant. We will be using batteries. The one that we are going to be calling two different things is this thing called loads or resistors. If it's a resistor, it means resistance. You should have learned that resistance stops the flow of electricity. The more resistance you have, the less current you'll have. These are going to be anything that you want to power. Your cell phone, your light bulbs, your radios, your lamps. Anything that you want to power is going to suck up that electricity and cause resistance, which is why we call them resistors. The more loads you have on a circuit, the more chance you'll be able to blow out the circuit or short circuit it because you have too much resistance to stop that current from flowing. Now all currents have to have the three different parts. You have to have wires, you have to have something to power, and you have to have a power source. Most circuits contain a switch, but they are not needed for the circuit to run. They are optional. So a switch, as you can figure from a light switch, is something that is used to control the flow of the current. So a switch can either turn on the flow or turn it off. We use two different terms. If a switch is closed, we say that it's turned on. In other words, a closed switch completes the circuit and allows for a complete path for electricity to flow. The light bulb turns on. If the switch is open, we say it's turned off. In other words, you open the switch, you now create a gap. There's a gap here. Electricity cannot flow from one end to the other, so we say that it's turned off. Alright, so now that you know some parts of a circuit and know what a circuit is, that's all good. You can easily draw a battery and light bulbs, but that might take a while. So when we talk circuits, we use circuit diagrams. What a circuit diagram is a blueprint or a map to show us what the circuit looks like and how it's put together. So these are some of the symbols that you're going to be seeing. The first one is the switch. Now there are two ways to represent a switch. One way is for an open switch. An open switch is represented with kind of it looks like a little open door. This is the blueprint to represent an open switch. As you can see, there is a hole here. In other words, electricity cannot flow here because there's a gap. So remember, when the switch is open, that means the lights are turned off. Another way to represent a switch is by a line with two dots in the middle. This represents a closed switch, meaning the door is closed. Remember, closed switch means electricity can flow. Lights are turned on. The next symbol is a battery. The main way to draw a battery is one end that has a short little end and one end that has a long end. Now this is not represented as a gap. This whole thing is representing a battery. Sometimes you might see a battery drawn with more lines in it. That doesn't necessarily mean that there's two batteries. It just is another way to represent it. Two batteries, however, would be shown like this. You'll have several lines. That will mean two batteries. So if you see anything that has a short line and a big line with a little gap in there, that is a battery. Any straight line connecting any part, that's your wire. It's very important that when you do your lab tomorrow, when it tells you to label all parts, do not forget the wires. That is the one part that everybody always forgets to label. You'll get points off. Always, always, always label your wires. The last one is represented in many, many ways. Your loads or your resistors can be shown on a circuit diagram or your circuit map by either having jagged lines. It might have jagged lines inside a circle, or what you're going to be seeing tomorrow in your lab is a circle with an X in it. The circle with the X in it is used mostly to represent light bulbs, which is what we're going to be mainly using for our circuit diagrams. So make sure you know these symbols, make sure you can draw them. You will be asked to draw circuit diagrams as well as label them and identify them. So it's very important that you know these diagrams. The main part for these circuit notes for your test is the difference between series and parallel circuits. Hopefully most of you that took Mr. Clausen's class know what series and parallel are. A series circuit is the simple circuit. It's a circuit in which all parts are connected in one single loop. In other words, there's only one path for the charges to flow. It goes from one end all the way to the other. This is where you have your batteries. Your batteries are a single series circuit. Electrons can only flow in one path. So some examples of series circuits include burglar alarms or your old-fashioned Christmas tree lights. Now I'm sure you guys are way too young to remember the old crappy Christmas tree lights that if one goes out, the whole thing goes out, but it's an example. Burglar alarms work the same way. In a burglar alarm, if one part of your circuit gets opened, say a window, it breaks a circuit and it sets off an alarm. One part goes out, the whole thing goes out, causing an alarm to set and the cops to come to your house, make sure we're okay. So again, we have a real diagram, but you're going to be seeing the circuit diagram, and this is what I wanted you to get used to. Yes, they're drawn in squares, but keep in mind that wires usually don't go in a square, they go in a loop. So I don't want you to be confused when you start building these and it doesn't look exactly like the square. This is your diagram. So tomorrow when you do your lab, you're going to be putting this together as a map. You would have your battery, connect wires all the way to a light bulb, connect another wire to another light bulb, connect that all the way back to your battery. If you can flow one way, so you take your finger and you can flow through one end of the battery to the other end of the battery without picking it up, you have one single path. This is a series circuit. Now earlier I said that a series circuit was your easy one. That's the big advantage to a series circuit. They're easy to design and easy to build. It's one loop, one path. However, series circuits aren't really used in today's society because of the very big disadvantages. I already told you about the Christmas tree lights, but if one light bulb goes out, all others in the circuit will go out. That's because they're on the same path, and in one, this now creates a gap. If there's a gap in the circuit, your electricity can't flow. Okay? Major disadvantage there. The other disadvantage is if you add more light bulbs to the same circuit, all the other light bulbs are going to become dimmer. This is because there is now more resistance on the loop, and as you remember from Ohm's law, more resistance, less current. If your resistance increases, then your current is going to decrease. Remember how to calculate that. Also think about this. Think about you sharing a room with a sibling. If you share a room with one sibling, everything's split in half. You have less space to spread out your stuff. If you add a third sibling in your room, you have even less space. Space is kind of like current. The more people you add to your room, the less space you're going to have. Hence why the light bulbs get dimmer. There's less of it to go around because you have to share a room or share the current. The second type of current circuit you're going to be dealing with is called a parallel circuit. Now, from math class, you know that parallel means that they are parallel from each other. They're going to be the exact same, just across from each other. So a parallel circuit is a circuit that has many separate loops. There's several paths. In other words, there's more than one path for the current to take. In other words, it's a detour. So instead of having one path that you have to follow and you have to go through it regardless of anything, this one has two paths. You can either go down one road or you can go to another road. Think of it going to school from your house. There's not just one way to get there. There are several different ways. One way may be shorter than the other, but there are still multiple ways that you can get from your house, the battery, to your school, back to around. So a trick to use this one is if you can take your finger or a pen, and if you follow your line from one end of the battery to the other end, if you can go two different ways, you have a parallel circuit. Two different paths. They're parallel from each other. Now, a parallel circuit is something that we use in all buildings. This one makes sense. The parallel circuits are the ones that have greater advantages more than disadvantages. The main advantage here for a parallel circuit is it solves the problem of the whole one goes out, the other goes out too. In a parallel circuit, if one light bulb goes out, the other light bulbs stay on. It's because there is another path for the current to take. If this road has a hole in it or a gap, then you take a detour and you go on the other path. There are more ways that current can travel to the other end. It doesn't matter which light bulb goes out because there's always another path to get back to the light bulb. There's always another detour. The other advantage to a parallel circuit is if you add more loops or add more resistance, you're actually decreasing the overall resistance. You're increasing your current. A parallel circuit is going to make the light shine as bright as possible. With less resistance and more current, it's like you're sharing no room with siblings. It's like each of you have your own separate room. This sibling has their own space, and this sibling has your own space. Yes, the current is flowing on this wire, but because you're on two separate loops, you're actually decreasing the resistance and increasing your current. You have more space, your sibling has more space. You are a whole lot brighter. Your light bulbs are a lot brighter. If you want to make a circuit that has the brightest light bulbs possible, you're going to want to make a parallel circuit. Series circuit has dim bulbs, parallel has bright. The only disadvantage to a parallel circuit is these are very difficult to build and design. You will see tomorrow when you start building these that as you add more light bulbs or more resistance, it's going to be a little bit harder to construct a parallel circuit to make it all work. This is the problem they run into buildings, and it becomes a little bit more difficult to wire than a series circuit, but the advantages outweigh the disadvantages here. Now you have this in your notes that I gave you that you're supposed to be filling out on Google Classroom. This diagram is extremely good to keep. On here you have two circuits. We have circuit A and circuit B. So circuit A and circuit B are real life drawings of what you guys are going to be basically building tomorrow. They will each match a diagram down at the bottom. Now before we begin, I want you to label the parts of your picture. Circuit A is a series circuit because it has one path to flow, one loop. Circuit B is a parallel circuit because it has multiple paths that the circuit can flow. Down here at the bottom, the first circuit diagram, this is a series circuit. Notice it's in one loop. This one matches circuit A. Notice how the switch, the battery, and each of the light bulbs are roughly in the same place as the exact picture up here. This is what I mean by this having a blueprint or a map of how you build it. When you build your circuits, put the pieces in the order and just connect them with the wires and you'll get your circuit. This one is a combination of a series and a parallel circuit. Notice it has a single loop here, but also has a parallel branch here. We're going to talk more about this one in a minute. The last circuit diagram is your parallel circuit. Notice how you have multiple branches for the current to flow. This one happens to match circuit B. It has 3 different branches where it doesn't matter if one goes out, the others will stay on. Now look at the questions that you have. I want you to look at these and answer as many questions as you can. For instance, in this circuit diagram here, what would happen if bulb 1 went out? What would happen to bulbs 2 and 3? Or what would happen to bulb 1 if bulb 2 went out? The answer is, if one of these lights goes out, the other ones go out. If you cut off one, you're creating a gap in the circuit, causing all other light bulbs to stop working. That's the disadvantage of a series circuit. If you look at your last circuit diagram, we have the same question. If light bulb 1 goes out, or light bulb 2 goes out, or light bulb 3 goes out, what happens to the other ones? It does not matter which one of these light bulbs go out, because the other 2 will stay on. In other words, the path can go this way, or it can go through here. It does not have to go through this branch. Only this light bulb will turn off. All your houses and schools are set like this. So that way when you're watching TV and your light bulb goes out, your TV doesn't automatically turn off. That's a parallel. That's your advantage of a parallel circuit. One goes out, the others stay on. Now here's a trick. Look at this combination of a series and parallel circuit. What happens if light bulb 1 goes out? If bulb 1 goes out here, yes, you have a parallel part. However, because bulb 1 falls before the parallel branch, this knocks out your entire circuit. In other words, this acts as the series switch. However, if we say take out bulb number 2, the bulb 1 and 3 will still light because there's still another path for them to flow. Bulb 1 is the only one that controls, just like the switch, the path of this current. Bulb 1 goes out, they all go out because you're in a series with bulb 1. But if bulb 2 or bulb 3 go out, you have another path for the current to flow. So then that acts as a parallel. Be careful when you see combinations of these because you will miss them every time unless you take your finger and follow your path of your charge. Finish answering the rest of the questions on these note pages. Then, if you still have time, please review the information that I have on Google Classroom to review for your test. If you're still having trouble with circuits, there's a great Blobs, it's called Blobs, it's like a game that you can play through and it'll help you with circuits to help you understand series and parallel with the bulbs a lot more. If you feel like you have circuits down pretty well, there's an excellent gizmo called Circuits, and you actually can build circuits and find out what happens when you add more in a parallel or series. You will see the lights getting brighter and dimmer. There's also your study guide on Google Classroom. The answers will be posted before your test. And that's about it. Please welcome your new sub today, and if you have any questions, please ask him. He knows what he's got. Good luck.